In this example, we'll talk about sprintf, printf, and scanf as we go over formatting our output. Formatting a string to present it as output. Well, printf, this is going to output a formatted string. You might be wondering what a formatted string is. We'll take a quick peek at some code before we get into the full explanation in the examples. As printf, this is going to return a formatted string. So printf is going to be used like your normal echo and print to output, to get it ready for the browser, output some text. As printf allows you to return a string to be used in a variable, for example, or in different ways that you can use strings. As scanf, this is going to parse formatted string input, and this is important as well. They all use a special syntax, very similar, and they have great functionality. Let's take a look at some examples. Printf, as you can see, %d, there's a space in between, %s, these are two little placeholders here. The %d is going to hold decimal values, which are our integers here, and then we have a string here, which is %s. So it's substituting. You can think of this in terms of a template. So a template string is a good example of describing this. We're formatting these values here to meet specific demands here. This is a simple example, but at least it's keeping this in the types here as far as integers and strings are concerned. That's going to substitute them into that string. We can change these as many times as we want, and then printf just prints things out like echo. We're putting the format here first. We have our variable comma separated list here, as many as we want. It has to match the number of placeholders that we have here. So that's how you just print it out like you would use echo or print. As printf, this is going to return a formatted string. So you can fill a variable like you see here using the special syntax. It looks a little different here. We're formatting a month, day, and year. This makes sure we have 4 places here for the year, the month, and the day. D again is decimal, so it's working with our integers. But that's going to put that 0 in front for our months and days. And again, these are comma separated. So sprintf does some special formatting, and then it passes it back into a variable that we can use instead of just printing it out using printf. We have more control. And then we have scanf, 2 S's in front there. This is going to format things, and you can see that this is taking a string. So we take in a variable that we set here, and then we have our space separated list of different types here, the formats that we want to use, and it's going to format this string here and pass it into this list of variables here. List, open paren, and then your comma separated list of variables, close paren, and then the equal sign, and then the scanf function here. And that's going to actually create these variables. It's going to fill them up, and it's a nice way to bring in information into our variables in a formatted way. Very nice. So that's the difference between sprintf, printf, and scanf. So let's jump into the example where I go over this code in much more detail. Here we are going to be looking at sprintf and printf. And as you can see, we're also going to look at scanf, scanf. And this deals with formatting output. And what we're going to do is take regular strings and characters and numbers, and we're going to format them very nicely based on a special character that allows formatting. And as you can see, if we slide to the bottom, we're going to be getting different representation from binary to just regular ASCII characters to unsigned numbers that are just positive, no negatives, and then scientific notation, decimal places, and even hex and others. So what we need to do is first go over how these functions actually work and why they're different than echo and print, for example. Well, the first thing that we need to do is take a peek at our file. We can uncomment the top lines here. This is the formatting output file. And you can see that we have an integer, a string, and then we have this format string. And the format string uses this %d and %s. Well, what that is doing is saying, hey, this is a template string. This is a format string. What we're going to do is substitute in variables for these 2 placeholders, %d, %s. %d deals with integers, %s is going to take a string, just a string. Now PHP is very flexible with the types, as we know, but it does become useful to actually sort these types out and use them effectively as we wish. This is going to ensure that the type is going to be used as we intend it to, and we can see other examples later on that are more complex or that have a different variation of data. So when you use printf, you're actually going to deal with that format string. You can pass a string on there as well, literal string, and then a comma separated list here. And what that does is the variables are passed in order that they're going to be used in the template, and you're going to be converting to that particular type. Now, you're going to force that type or ensure that type. So number is going to be a decimal. Very easy to do that. And you want to look up the full details of printf and sprintf for more information. This is definitely coming from the C world, but PHP is very C-like, as I've mentioned. So then the next thing is to use getDate. And that's going to actually grab the date into an array, which is quite exciting. Let's take a peek at that real quick. There you go. You can see the array as we're used to, and you can see all different things, the minutes, the hours, the day of the month, etc. And then the weekday, things like that. And we just refresh that. The time is always going to be changing. We have the seconds there as well. The month, the day of the month is the 4th day of the month, and then we have the weekday. And the month as a number, the year, and then the day based on the year, etc. Names for the month and the day as well, and things like that. So you can use whatever you wish to use there. It's very effective. What we do is grab the year. Since it is an array, we can just use it with a key there. And then we have the month and the weekday because we want to actually grab the integer there. And you notice that that 1 only has whatever numbers here don't have prefixed zeros in front of it. We want to ensure that. So what we do is we put the 04 there to make sure we break out to 4 digits. Anything that needs a 0 in front is going to be the prefix of 0. Doesn't work so much with the year in this case, but with the month and the day, it comes in handy when you have a month or day that's 9 and under to 1. So it adds that 0 there for us. And if we look, yes it does. 03, 05, and 01 prefixed for us. So this first example just takes the actual date, and the second example takes information that we pass. Notice the 1 here. And this is using sprintf. And it's just passing information right here on the string, right here in the function, without doing a regular string like you see here. So then we have the year, the month, and the day. These are comma separated, and you can have as many as you want, and that's going to break it out with these dashes in between. And it's very nice and handy to use that. And you can use that as you wish. Another way to do that further down is we're just going to pass in that integer and a string and use the format like I mentioned. Just output here so we can take a peek at it. But we look here at the bottom one here, and you see that we don't have a day here. Let's take a look at the code. Well, in this case, month is a capital M. Don't forget to change that to make sure it's all lowercase. And January, if we refresh this, is still not output. That's because we're dealing with a day here, and this is wanting numeric data in order to process that. Sprintf isn't that smart. We're formatting our numbers and things like that, but it's not doing so much work for us. There are other ways to do that using the date functions. Here's a way to work with scanf and substring and have things work out for us quite nicely. January is written out. It's separated by spaces here. And what we can do is grab that based on scanf. It's going to scan this line and break it out like we've seen with other functions. Break it out by space, but in this type of format, we can be even more specific. And then we have an echo. So what we're going to do is break out the year, month, and day, because this is going to return an array. And because we're using the list function here, this is going to put those array values in these variables as we've seen, and that's going to break out the invoice date. And then since we have the month, we can just grab the substring, 0 start point, and then 3 characters, the first 3 characters, and that's going to be JAN, and it's output quite nicely, as you can see. So the other representations that we can use are binary, character data. If you just want a single ASCII character, for example, pass in a number, an integer, and get the ASCII equivalent. A decimal number that is positive and negative for D. Scientific notation with E. If you don't want to deal with negative numbers and you want to force a positive number, use unsigned. Unsigned doesn't allow negative numbers. Same number without the negative sign. Floating point, octal, string like I mentioned, and hex. Lowercase letters can be accepted with the lower x, and uppercase letters can be accepted with the upper x. As we know, hex can work with A through F in those hexadecimal values. All right, so we continue, and we have a number here, a big number. We have an unsigned number, which is negative. We have a character, 65, which translates into the ASCII equivalent of F. So if we take a look at the source code, we're going to see that the %B is going to turn this number into binary representation, which is really cool to do that. Very easy. The string, of course, just a string. And then we see the C is going to turn 65 into an F. So it's working really nice for us. Other functions to do that as well, but it works nice when you need everything on one line in regards to these functions. Decimal, unsigned, takes care of that negative number for us, as you can see. We'll see that in the example. Scientific notation, we have the F for formatting our numbers. You can see we have a certain amount of decimal places there. Octal, and then hex. Lowercase letters, and then uppercase. And it works nice if you're doing things with colors and things like that that you normally do with your HTML. You can do that with PHP on the server side as well. And then we have the decimal here. As you can see, plus is going to force the sign to be displayed. So plus adds a plus, basically. And that's a similar format. So you can add characters that influence and do different things, which is really nice. So just as an example, you can see with the unsigned, this first number here doesn't matter, it's positive, but the second one will eliminate the negative sign. And the C, 70, will convert that using this notation here. Convert that to the character equivalent. And also notice that I mentioned this before, but the double % is going to let us take this literally. The % is going to actually be echoed out or printed out to the text or the screen or wherever. And because we're using double %, we're telling PHP or this function to ignore this type of formatting for now, because we're going to be passing a % sign next, and that means just use both of those and just display 1% sign, like you see here. So keep note of that. Check out the escaping functions video for more information on working with that, and that came a little bit earlier. So that's how we can actually format our output quite nicely. You can do much more advanced things as well, but this definitely is a nice overview. Definitely look at the functions and how they work and get into the details.